So, welcome to our last lesson for the term. Excellent. So, today we're going through, we've got some notes up here, and this will be enough for us to address exercise 4E and 4F. This is a great exercise. It's a consolidation of some skills that we learned in quadratics, and so we get to reaffirm those skills we did in quadratics and develop them a bit further for cubics and quartics. Now, I want us to just, before we begin, think about this. We know if we have the equation of a line, how many roots does it have? One. It has one root. It cuts the x-axis once. All right. How about a quadratic? All right. We can have a quadratic, and it can cut the x-axis twice. This is very interesting. We have x to the power of 2. We have 2 roots. We saw we have a linear equation, x to the power of 1, 1 root. A cubic equation, all right, that's what we're going to be looking at today. Cubic equation, x to the power of 3, 3 roots. Okay, so basically the power that it has, x to the 2, it can have up to 2 roots, but we also know from the discriminant that a quadratic could have no roots or 1 root. All right, the same with a cubic, it can have up to 3 roots, a quartic up to 4 roots. That's how many solutions it can have. So that's what we're going to explore a little bit today. Now, the other thing I'll get you to draw your attention to is at the top we have a table, because what we're going to be doing is expressing these things in linear factors. If we have the function cross the x-axis once at a, then x take a is a factor. All right. If it touches the x-axis, so it comes down, touches and goes back up, then we have x take a squared, and we saw that with quadratics. It was a double root. So what we can see here with the first one is that we cut the x-axis 3 times, that the roots are -3, 1 and +2. So we can straight away set this up to be the equation of a polynomial. We always start like this, y equals a, and then we just multiply it by each factor. So the first one is going to be x take away 2, the second one is going to be x take away 1, and the third one is going to be x take away -3. All right, so I'll simplify that a little bit. X take -3 is x plus 3. All right, now we need to determine this value of a. And just like we did with quadratics, we have to use some piece of information on the graph. Now we've used this one, we've used this one, and we've used this one. They're our roots, so we need to use this piece of information here, the y-intercept. We have when x is 0, y is 3. So we're going to plug that into our equation here. We'll put 3 where the y is, and 0 where the x is. Okay, then it's just a matter of simplifying. On the left-hand side, we've got 3. On the right-hand side, we have a times -2 times -1 times +3. So this is going to become 2 times 1 times 3, 6a. Then we'll divide both sides by 6 to get a by itself. A is 3 on 6, which simplifies to half. Okay, so we determine the value of a, and that means the equation of this cubic is half times x take 2 times x take 1 times x plus 3. And what we have done there is we've expressed the cubic as 3 linear factors. Here's a linear factor, here's another, factors because they're multiplying each other, and it shows us the roots, doesn't it? We can see the roots very clearly. Now, one skill we looked at last lesson is that we could fully expand this and express the cubic in general form. We'll only do that if it asks us to. We're not asked to in this question, we're just asked to find the equation of the cubic. So if you were to now graph that on your graphics calculator, you would get exactly this graph. Gorgeous. Okay, on to B. So we'll always start with y equals a out the front. That's what we call our dilation coefficient, because it's going to stretch it or compress it. Here we have a dilation coefficient of +1/2. Y equals a. Now, we can see we have one linear factor of x take 2. All right, and then what's going on here is that it touches the x-axis. It comes down, touches it, and goes back up. So that occurs at -1, so it's x take away -1, but it's squared, okay? And the reason it's squared is we can derive that from our table above. If it touches, then the factor is squared. So I've got x take, the root is -1, x take -1 squared. So we'll just simplify that a little bit first. All right, and then we need to use another piece of information to determine the value of a. We've used both of these roots, so we'll use this one up here. We have the y-intercept. When x is 0, y is 4. So we're going to plug that into our equation. 4 where the y is, 0 where the x is. All right, so you can jump straight to that step there. You don't need to write it as 0 take 2, 0 plus 1. All right, it will just be -2 and +1. And we'll evaluate that. What we're going to have here, bed mass, 1 squared is 1. -2 times 1 is -2. So we have 4 equals -2a. We'll divide both sides by -2 to get a is -2. And then we'll state our solution. Therefore, y equals. All right, on to our third example. Okay, we'll always start with our dilation coefficient a times. Our first root is a linear factor, x take 2. That's a very clean cut. And then what we can see happening is we have what's called a flat cut. All right, and that's hyper exaggerated. What we can see happening is that it crosses the x-axis here, but it's also horizontal at that point. So I've really tried to exaggerate that feature. And that corresponds with a cubic root. Okay, we can see that that's the third column in our table. We have x take a to the power of 3. So in this circumstance, it's going to be x take away what's the coordinate where it occurs? That's going to be 0, and that's to the power of 3. All right, to the power of 3 because it's a flat cut. All right, so this can simplify a little bit. X takes 0, well, that's just the same as x. So we can write it like this. And in fact, probably the way the book will present it will be like this. It's x to the 3 times x take 2. We don't need to put it in brackets because there's no addition or subtraction next to it. Remember I was saying the other day that order of multiplication is the same. 2 times 3 times 4 is the same as 4 times 3 times 2. It doesn't matter what order we put them in because they're multiplying each other. And technically we would prefer to write it like that, generally in alphabetical order, and brackets coming last. Okay, so there's that. Now, when I'm looking at this, right, over here we saw we had a single root and a double root, and so that's a cubic equation, right? We have x to the power of 1 times x squared, that's x to the power of 3. Here we have x to the 3 times x to the 1. The leading power is going to be x to the 4, so this kind of function is a quartic, all right? So we're starting to lead on to quartics. Now, the textbook breaks it up, 4e is cubics, 4f is quartics, but we're doing both at the same time because the skills really do overlap. All right, so we've got the basic function here, and we need to determine that value of a using a piece of information we haven't used already. Now, we've used that, and we've used that, and we're told one more piece of information. We have when x is, let's say, -1, y is +3. Okay, so we're not told the y-intercept. Well, we are, it's implicit, but we can't use that. That won't reveal anything to us because we've already used that piece of information. All right, we've already got when x is 0. So we have to use this one, which is when x is -1, y is +3. So we're going to substitute that in. So I'm going to put it in here. We'll have 3 where the y is. A stays out the front. -1 to the power of 3. Times -1 take 2. Now, it is imperative that when you're performing this calculation, all right, minus 1 to the power of 3, it won't matter so much in this circumstance, but it's really important that it's minus 1 and then to the power of 3. All right, it's x to the power of 3. The x value is minus 1 and then to the power of 3. So you can put it in your calculator. It just means minus 1 times minus 1 times minus 1. What it's going to come out to is minus 1 times minus 3. And so we'll get 3 equals 3a. And so a is 1. The value of a is 1. And so that means the equation of this Quartic polynomial is x to the 3 times x take 2. All right, we don't need to write the a value up the front if it corresponds with 1. So some of these questions are presented with a graph. Some of them will give you a worded problem that you need to visualize and then answer the question. Okay, so let's have a read of question 2a. Find the equation of the following polynomials and hence graph them. I'm going to graph them first so that we can visualize it. We have cuts the x-axis at minus 2, 2 and 3. So on the Cartesian plane, we've got minus 2, positive 2 and positive 3. And has a y-intercept of minus 24, so here. So all we have to do is an equation that has those features, all right? If it cuts the x-axis here and passes through this point, it has to go like this, all right? It can't go like that because then it's not going to have a y-intercept unless it cuts it down there again. It has to have this shape. It has to come down here, cuts there, comes up here, and then we know it cuts there again. So this is the shape that it has. All right, so if we're going to describe the equation of this, we'll start off with y equals a times, and then we just go, what are the factors? The first one is 3, x take 3, x take 2, and x. We can jump straight to x plus 2 if you're starting to be comfortable with that. X take minus 2 gives you x plus 2. Then the coordinate, we have when x is 0, y is negative 24, sub in. Process. So that's going to be positive 6 times 2, that's positive 12. We divide both sides by 12, and we'll have a is negative 2. So the equation of this polynomial then, okay, last one. So question 2b, this graph, we're told it touches the x-axis at x is minus 3 and at x is positive 2 and has a y-intercept of 36. All right, so they're the features. And if it touches there and passes through this point, it has to do this. Touches there. All right, so it's looking something like that. Okay, so we'll set it up. We're going to have y equals a times. Now it touches at x is 2, so that means that's a squared factor. And it touches at x is minus 3. So x take minus 3 squared. All right, x take 2 squared, x plus 3 squared. If it touches, then it's a squared factor. And we have a y-intercept of 36. So when x is 0, y is 36. So we'll put 36 on here. So that's going to be positive 4 times positive 9. We get a is 1. Alright, so just a matter of processing there to get our final answer. Okay, really good. So for this exercise, We'll start with 4E, question 235, 4F, question 135. I would anticipate we can probably finish this in the lesson, which means you can have the first week off because I've got a holiday homework present for the second week. All right, so yeah, let's get on to the textbook.